Okay, so we have the problem to find least common multiple of this pair of expressions and this pair of expressions. The first expression. Factored form. We could write it like this. Now, there are tricks you can use with exponents and stuff, but I choose to write two x plus ones here because people get mixed up when they first encounter the exponents, okay? Whatever the exponent is, x plus one times x plus one is this. Even though you could write this as x plus one squared, you're not going to see it as easily if we write it as x plus one times x plus one. So the question is, least common multiple. Now, of course, you want to go back if you haven't, if you weren't in class last time and didn't see the details of what I did, because I'm going to do it pretty fast today. You need to go back there and check that. Okay, so least common multiple is what? Well, we got to have x plus two times x plus one. I'll just put a circle around that to indicate this is the same as this, right? Now, we need a pair of x plus ones here, okay? Because we have x plus one times x plus one. In the least common multiple, we've got to contain this expression and we've got to contain this expression. If we have this expression already, then this one's already contained. Okay. What else do we need in order to contain this? Well, all we need is an extra x plus one. So now this expression contains this expression. Okay. And it contains this expression. Okay. People often try to write down two more x plus ones here. Well, that's a common multiple and you could actually use it, but it's an extra pain in the neck, okay? It's an extra term. It raises the degree of your polynomial by one. It adds a bunch of extra terms if you want to expand it, okay? You don't want that. You want the least common multiple. Now, the analogy to this let's take the least common multiple of 8 and 20. Okay. Factored 8 is 2 times 2 times 2. 20 is 2 times 2 times 5. Now you get that by doing the prime factorization, something encountered first week of the course. You don't remember that? Well, I'll refresh your memory. You just divide 8 by the smallest number, the smallest prime number. Okay, prime number is a number you can't divide by any other number. 2 is the smallest prime number. Okay, now when I say the smallest number you can't divide by any other number, 1 doesn't count. Okay, because 1 is 1 times 1, but well, you just don't want to, you don't want to mess with 1. Okay, so 2 is the smallest number you start with. 2 divides 8, leaves you 2 times 4, right? And then 2 divides 4, gives you 2 times 2. So you have 2 times 2 times 2. You just keep dividing 8 by 2 until you run out of 2's to divide it by. Okay, 20, you can divide it by 2. Okay, you get 10. You divide 10 by 2, you get 5. Okay, and 5 is prime. Nothing else divides 5. 5 can't be expressed as a product of 2 other orders. So there's our factored form. So the LCM is 2 times 2 times 2. And I'll put a yellow circle around that. The 10. That times 5. And now we have these three factors inside the least common multiple, and these three inside the least common multiple. And then that equals, of course, 40, which is the smallest number that you can divide by 8 and by 20. Now, you should know that. So if you don't, better start reviewing. There's going to be final exam in less than a month now. Okay? Month from today is, I think, the day after finals, and day after that's possible to take the final. So you're going to need to start reviewing, and also make sure you keep up with the last few assignments. Okay? And the main assignments you have to worry about is just what we get this week, and then what we get today, in other words, and what we get next week. Okay? And after we come back, there's another assignment that'll, be due, but you really want to think in terms of reviewing, because once we get back, we've only got another week of classes and then it's final. Okay? So we need to make sure we want to start reviewing, and this would be a good thing to review so you really understand what's going on here. Now, why do you need to do this? Well, what if you want to add 5/8 plus 13/20? Okay. Well, you want to put that all over 40. So you do 5/8 times 5/5 plus 13/20 times 2/2. Then your denominators will both be 40, and you can add your numerators, which will be 25 and 26. You get 51/40. Now, again, did that in the first week, and something you learned to do in 5th grade, except you probably didn't do 5 factorizations. It never had to do again because somebody put a calculator in your hand and said, you don't need to know that. They didn't really say that, but that's the effect of it, okay? And it never gets reinforced. So if you're rusty on it, it's probably been a while since you were in 5th grade. In my case, it's been, 6 or 7 years. That's a 5th grade task, except for the least common multiple thing. Okay. So you can master, make sure you get that master, because you're not going to understand the next assignment unless you do. Okay. So anyhow, there's least common multiple. Or maybe you're going to understand the next assignment. When you do, you say, aha, now I understand this. Okay. Could be either way. All right. Now, here. It's very similar. You got x minus 4 times x plus 7 times x minus 2 and x plus 7 quadratic square. Well, we start with either one of this one. So we're going to write this one down. Now, no matter what else we multiply by this expression contains this, right? What else do we need to contain x plus 7 squared? Well, that means we need x plus 7 and another x plus 7. We've already got an x plus 7. So all we got to do is write another x plus 7 on it, and there it is. So that this thing is contained. So this one is here, and this one Well, it's actually between two factors that aren't right next to each other. Down here, we could circle the whole thing. The x plus one times x plus one. It's split, but it's still there, and you can put them in any order you want. Okay? Now, help and math probably want you to express this as x minus 4 times x minus 2 times x plus 7 times x plus 7. Actually, they wouldn't want that. They would probably want x minus 4 times x minus 2 times x plus 7 quadratic squared. Okay? Now, people that did the assignment all appear to have made 100% on it. Okay? So it's not that difficult of an assignment, but what it leads to is one of the more challenging things in intermediate algebra. So we're going to dive right into that. Okay? And we'll use these expressions. Let's just say, first of all, that we want to add two of these expressions. Let's say we want to add, or we want to add rational functions that involve these two expressions. So let's just say we want to add x squared plus 3x plus 2 over x plus 7 squared to x squared plus 2x plus 1 over x minus 4 times x plus 7 times x minus 2. And well, we want that to equal something over the least common multiple. Now, we've already seen least common multiple of this contains this. But it's also got to contain another one of these. There's our least common multiple. But didn't get it in there. Okay, that's written a little small, but it's the same thing as this. If we have it in this form, then we can just add our two numerators and just have this as one denominator. That's why we do a common denominator. Well, we don't know what this is going to be or what this is going to be, but we're going to write it like this. I'm just going to write down this term or this factor, this term, sorry, it's a term. And I'll circle this. Just to indicate that this is the same as this. And then I'm going to write plus this. And I'll circle this one in a different column, just to show that this is identical to this is identical to this. Now, it's not in this form because this denominator lacks something. And this denominator lacks something. So what is it that this denominator lacks? Well, let's start with what is it that this denominator lacks? What else does it need in order to match this denominator? So we found the least common multiple. We did that already. And that'll be your least common denominator. What else do I need in this denominator in order to match the least common denominator? Okay. I did ask people to write this down. What's missing here with a big heavy circle? One culprit wrote it down with an invisible circle. Now, it was invisible to me from a distance, but when I got up close with a magnifying glass, I could see sort of the faint outline of a circle there. Okay, and I said, don't waste my time like that. Now, okay. Anyhow, let's be efficient. When I say a big circle, I mean a big circle. Okay, well, what you need, of course, is the x plus 7. And I will put a circle around it. But that's, you were supposed to. Okay. You wrote it down, and he wrote it down where it belongs, so it's good. Everything but that circle. Okay, now, we can't just slap that in there. Okay? Unless we also slap one into the numerator. So now what we've essentially done is we've multiplied this fraction by this fraction, right? And that's completely similar to what I did over here, where we wanted to get 40 in the denominator. We can't just put 40 there. We have to do this in such a way that we get an expression that has the same value. You know, if you punch this into your calculator, you're going to get 0.625. You punch this into your calculator, you're going to get 0.625. It's got the same value because we just multiplied this by 5/5, which means we multiplied it by 1. And if you multiply something by 1, its value doesn't change. Even if that 1 happens to be 5/5. So it might look different, but it still has the same value. Okay. So there it is. Okay, now what do we have to multiply this one by? What do we need in the denominator that we're missing? Write that one down and put a big heavy circle on it. Okay, now what's missing is obviously, if we look at this and this, is the x minus 2 and the x, oh, it's an x minus 2 and an x minus 4, right? Okay. So we're going to have to multiply this by things are getting bunched up here. I didn't leave myself room to write this. But everybody knows what it is. So let me rewrite it. Okay. This is x squared plus 3x plus 2 over x plus 7 times x plus 7 multiplied by x minus 2 times x minus 4 over x minus 2 times x minus 4. So that now our denominator is going to be what it needs to be. And then it's plus okay, that should be at least halfway legible. And of course, then that equals x squared plus 3x plus 2 multiplied by x minus 2 times x minus 4 plus x squared plus 2x plus 1 multiplied by x plus 7, all over the same denominator. Now, again, we would probably not write one of these x plus sevens and just do an x plus 7 squared, but we're going to have to factor things, okay? And we're actually not going to be able to factor our numerator, but in simple examples, we might be able to, especially with your homework, which has been contrived to make it happen that way. Okay, well, now we can multiply out this numerator. And I don't really want to take the time to multiply it out. We'll do another example where we can more reasonably do that, okay? This is a little more complicated than most, but there's nothing inherently difficult about it. Once you have the factored form of the denominator, factored form of each denominator, you can figure out what your common denominator is, and then fill in whatever you need on each rational expression, each fraction. Okay? Well, let's look at a somewhat simpler example and see if you can do it. Now, okay, let's try. First, you have to factor your denominator. So I'm going to assume that everybody can do that. I say that knowing there's some members of class who can easily factor those, and some who haven't yet mastered factoring. And this is not the place to practice factoring. Okay, so if you don't know how to factor these, learn to factor so we can do these problems. Okay, you've got x minus 1 over x plus 2 times x plus 3 plus 2 over x plus 3 times x plus 3. Okay, now what's your common denominator going to be? We'll get that. Your common denominator is least common denominator. Make that an LCD. Okay, everybody's either got it or is just writing out the last few strokes with pen. So we can continue. Now, first of all, everybody correctly identified the least common denominator. We start out with the x plus 2 times x plus 3, which contains this denominator, but it doesn't quite contain this denominator because we need another x plus 3. All right. So now we can say that this equals x minus 1 over plus 2 times x minus 3 multiplied by, well, we need x plus 3 in order to have our common denominator. So we better have x plus 3 here. And then we have 2 over x plus 3 times x plus 3. And to get the common denominator that we need an x plus 2. So we can multiply by x plus 2 over x plus 2. And we get x minus 1 times x plus 3 plus 2 times x plus 2. In other words, this numerator and this numerator all over x plus 2 times x plus 3 times x plus 3. What's that equal? Well, x minus 1 times x plus 3 is x times x plus 3 minus 1 times x plus 3. And then we have 2 times x plus 2. All that over the entire random's denominator, x plus 2 times x plus 3 times x plus 3. So this gives us x squared plus 3x minus 1x minus 1 times 3 plus 2 times x plus 2 times 2. Well, that's plus 4. Over the same doggone denominator. Okay. And then we just add up all our x's. We've got an x and a 2x. It's okay. I said minus 1 here. It's minus 1x. It's careless. So we're going to have x squared. We have 3x and 2x and a minus x, which makes 4x. And then we have minus 3 and plus 4 plus 1, all divided by, well, I don't have room to write it out. I'm going to write it out again. Because then we're going to see what we have to do with this numerator. Okay? That makes sense? Everybody get x squared plus 4x plus 1, or did I make a mistake? Okay, somebody tell me I made a mistake, obviously. Getting horrible looks from one of these directions. Okay, so we've got this step here. Now there's a question about why this is a 3x, not a minus 3x. Okay. So if you go back to this step here, which everybody agrees with, we have x times x plus 3. Okay, minus 1 times x plus 3 plus 2 times x plus 2. Have that right? And that's over my denominator, which is, I'm writing it, x plus 2 times x plus 3 times x plus 2. Now, this is x times x plus x times 3. You would agree, right? And this is minus 1 times x and minus 1 times 3. And this is 2 times x plus 2 times 2. Okay? And I'll put parentheses here. Well, I don't want to do that because then I have a minus sign. That's going to confuse things. Okay. Now that's over. Okay, x plus 2 times x plus 3 times x plus 3. And I could have closed that parentheses. Okay? Make sense? X times x is x squared. X times 3 is 3x, and it's a plus. Negative 1 times x is minus x. Negative 1 times 3 is minus 3. 2 times x is 2x. And 2 times 2 is 4. Okay? So that's why it's plus. Now, that's going to give us x squared. 3x minus x is 2x, but then 2 more x is 4x. And then minus 3 plus 4 is plus 1. And it's over x plus 2 times x plus 3 times x plus 3. Now, what we've got to be careful of is, does this trinomial here contain a factor that's equal to one of these? Okay? In other words, if this factored as x plus 3 times something else, then we'd have to divide the x plus 3 into that x plus 3, right? Okay. Now, if this is plus 3 instead of 1, this would factor as x plus 1 times x plus 3. Okay. So we could have an x plus 3 up here. So for that reason, we factor the numerator. Well, it turns out anything you do to factor this numerator is going to fail. Might be a little hard to read down here. I'll say also as a side comment, b squared minus 4ac isn't a perfect square. If it is a perfect square, you won't be able to factor it. And you recognize b squared minus 4ac is that thing under the square root in the quadratic formula. Okay? So you can always test a trinomial of degree 2, like a quadratic expression, to see whether it's factorable or not. Okay? Now, why to factor? What if it had been this? X squared plus 4x plus 3 in the numerator instead of in the denominator. Need a little more room there. Still needs a little more room. Okay. If it had been this, you could factor the numerator. Then we would get this, which just equals x plus 1 over x plus 2 times x plus 3, as long as x isn't equal to negative 3. Because if x is negative 3, we'd be dividing by 0. Even though we'd be dividing it into 0, we can't divide by 0 under any circumstances. So as long as x isn't 3, this expression is equal to this expression. If x equals negative 3, I think I said 3. If x equals negative 3, then the denominator is 0 and the expression is undefined. And that's going to have a lot to do with the graph of this expression, but that's something you encounter early November or early April in a pre-calculus course, okay? After you've developed a lot more machinery. Okay, so point is then that this expression would have simplified if we'd have had 3 here instead of a 1. Okay. And then what if we'd have had a 4 here? Well, then this would have factored as x plus 2 times x plus 2, and we would have been able to divide an x plus 2. All right. Any other numbers? And not going to work. It's not going to factor. But the lesson is, after we've gone through all this, and everybody's really good right now with this process, everybody got it, and everybody went all the way to the end with maybe one mistake where somebody had a -3 here instead of a +3, but everything was good. The whole process was good. So as long as you know how to factor, you can find your least common denominator. Okay. People didn't have much trouble understanding the least common denominator of this pair because everything was factored. Some people have problem with this because they haven't yet mastered factoring, but they will soon because factoring is actually easier than everything else we've done today. Okay. Just have to get in there and practice it. Okay. So once these are factored, it's easy to find the least common multiple. So factoring is the first task we've got to perform when we have something like this. Okay. Once it's factored, everybody can find the least common denominator. In this case, if your denominator hadn't been factored, then you would have had to factor it before you could find the least common denominator. Well, we already did that for a couple of expressions. And I'm going to go ahead and write this out the way it would have been written originally. Yeah, I'm going to have to do a couple more things I didn't anticipate, but I'm going to do it anyway because I think it might be useful. Okay. If this expression had been written I take it back. It's going to take me a minute to get that right. I don't want to have the delay, so let's go back again. This has been wait a minute, which one is over which? This is over the square. Okay, so I'm going to take it back to what it was. I was going to do something, but I don't want to multiply that out in my head. There'd be a chance that I get it wrong. My point is that if instead of x plus 7 squared, I'd have had x squared plus 14x plus 49, then you'd have had to factor that, and you would have gotten x plus 7 squared. And if this had been whatever it is when it's multiplied out, then you would have had to factor that. So again, you might have to factor both the numerator and the denominator, and that's my whole point. Okay. Now let's see. Let me take a quick look at what's common to make sure I'm giving you what you need. Okay, so if everybody picked up on this very, very well, I'm convinced that you're going to be fine on the homework as long as you can factor things. So if you haven't learned to factor, then do homework, okay? Because otherwise you're going to waste time spinning your wheels. You have to be able to factor. Now I'm going to switch gears and start talking about something that's going to be important to you early on at the pre-calculus course. Let's take the equation y equals x squared plus 5x plus 6. Okay? This can be factored. A couple of big questions when you have something like this. What value of x give you y equals 0? Anybody spot the value of x that gives you y equals 0? You show me with your fingers. Yeah. Okay. So what I'm saying immediately is if x equals -2, you are going to get 0. Okay. Is that clear? If you plug in -2 for x, then x plus 2 is going to be 0, right? X is -2, that's going to give you 0. And 0 times whatever x plus 3 is still going to give you 0, right? So if either of these factors is 0, you're going to get 0. Okay, so for what values of x is y equals 0? X is -2, then x plus 2 is 0. And if this is 0, since it's multiplied by this, y is 0. Well, this tells us two things. Let me write it up clearly more. So I have to get another line. Okay. we have an XY point where X is -2 and Y is 0, then that's the point -2, 0. So we get the XY point -3, 0. So we can do a graph of X versus Y. Now, draw me a set of coordinate axes. If you copy down what I've written, stop and do this. And show me where you think Y equals X equals -3. But whatever way you want to indicate it, I just want to see if you understand the coordinate plane at a certain level. Now, the way I want to indicate that, it's over here somewhere, right? You put it way over here, you put it real close, but most people put it somewhere about here. So this would be the line where X is -3. Now you want to lock that in because it's something that my pre-calculus students taken forever. Some of my pre-calculus students have taken forever to understand. Okay. Everywhere on this line, the X coordinate is -3. Okay. Because X is -3 here. And if you line off your axis 1, 2, 3, 4, 5, then X equals -3. Well, okay, the point -3, 0, X is -3, and Y is 0. Now, where is Y 0? Well, if you're lining off your Y-axis with 1, 2, 3, 4 here, and -1, -2, -3, -4 here, you'd say, okay, Y is 0 right there. Well, Y is 0 everywhere to the right and left of that point. So in any case, this is the point -3, 0. So the point -2, 0 is going to be between -3 and 0. Okay, between -3 and the y-axis. The closer to -3, about a third of the way. So we'll say that this is X equals -2. And this point is -2, 0. Okay. Now, X equals 0, Y equals what? As soon as you think you've got the number, write it down someplace in your paper, put a circle around it that I can identify. Okay? Okay, people understandably have a little trouble answering this because they've probably forgotten this formula for Y, since we got involved in everything else, right? So let's emphasize this or this. If you plug 0 in for X, what do you get? Can you show them with your fingers?
You said 0 is X, right?
Okay. I think somebody showed me 5 fingers. But remember, this is multiplied by this, not added. Yeah, there's 6 fingers, okay, with a big, apologetic, wonderful looking smile, okay? So that's fine, you got it. And of course, if you plug 0 into this form, it's even easier. You don't have to multiply anything at all. If X is 0, this is going to be 0, this is going to be 0, and you're going to be left with 6, right? It's going to be the same either way if I factor it, because this is always equal to this if my factoring is correct. Okay, so if x equals 0, y equals, well, zero plus 2, 0 plus 3, oh yeah, that's 6, right? Okay, well, where's that point going to go on your graph? Okay, very good. Very good. Everybody here. And of course, my distant students haven't seen this video yet, but everybody here. Okay, anyhow, so there's our picture. Here's the point -3, 0. We saw the point -2, 0. My labeling of -3, 0 wasn't visible a minute ago. And then this question, if x equals 0, y equals what? Okay, again, here's your rule. You take this one or this one. Either one, assuming your factoring is correct, they'll both give you the same result. Okay? Now, if you plug in x equals 0, you get 0 plus 2, 0 plus 3, which is 6. Or if you plug it in here, you're going to get 0 here, 0 here, and you're still going to have 6. Okay, there's where we are. Now, question is, where's that point going to be on your graph? Well, it's going to be up here a ways. Okay, so I'm going to draw a line here for y equals 6. And of course, the y-axis is the x equals 0 line. So I could even label it down here, just like I could label this line y equals 0. Then the point 0, 6 is where x equals 0 and y equals 6. That's here. Everybody needs. Okay. Now, should be obvious that we can't draw a straight line through these 3 points. Okay. What's the graph going to look like? It turns out that if it's an x squared plus something x plus something, quadratic expression, that the graph is going to be a parabola. And what's a parabola look like? Well, roughly, you can kind of see it as a U. That's not quite right, but it's close. Okay, now that's a lopsided parabola. It's lopsided to this side. Should have been further over this way. Okay. So I'm going to try to improve that a little bit. I should have started here. And then I'd have the right field. Now, my point is that this parabola has to be symmetric. It's got what we call an axis of symmetry. Right in the middle. Now, where is right in the middle? It's a vertical line right in the middle of the parabola. Well, if you got zeros here and here, then where's the middle of the parabola going to be? It's going to be halfway between the zeros, right? It's got to split the zeros to 2 points where x equals 0. It's got to split those right in half if it's going to be symmetric. Now, let's be sure we understand what we mean by symmetric. But if it goes through a point this far to the right of that axis, it's got to go through a point this far to the left. So we kind of automatically get this point. And now we can come on up like so. You get something that's a better looking parabola. Okay? It still needs a little plastic surgery there, but you get the idea. Okay. Now, this is a pretty good graph of that function. To the extent that I've drawn a pretty good parabola. Now, you're not used to drawing parabolas. And, you know, my parabola could be improved, I'm sure. But there it is. Now, what's the axis, what's the x value is the axis of symmetry? Go ahead and mimic my sketch there along with the axis of symmetry. write all my words, and then tell me what you think the X coordinate is halfway between the zeros. We've got some people in here that are drawing pictures that put me to shame. Somebody just did this and for the first time probably drew a parabola and almost drew a perfect, right? I'm envious, but respectful. Okay, that's very good. And fast too. These genetically gifted people. Okay. Axis of symmetry. It's between x equals -3 and x equals 2. And it's halfway between because of symmetry. Everything to the right of this axis of symmetry is a reflection of everything to the left. Okay? That's a mirror image. This half is a mirror image of that half. And so the axis of symmetry is that x equals -2.5 or 2.5 if you like. Okay, I'm going to give you a formula. Okay, first of all, x squared plus 5x plus 6, which you originally had, is ax squared plus bx plus c, right? Quadratic formula. We've done this time in quadratic form, haven't we? A couple of weeks ago. Pretty sure. Better, because we haven't been able to do it. Okay. A is 1, B is 5, C is 6. Okay. This is the quadratic formula for zeros. You seen this before? In this course? You've done the assignments. I think you do. I've got to go back and check the assignments because some people looking a little blank. Could be that people did the assignment in such a way that they always have the quadratic formula staring at them when they did all the problems and never remembered it. Remember the strategy. There's a video, so forth, so forth. Go ahead and use that information. But when you get the problem doesn't have a video, put all that stuff away and see if you remember. You probably won't the first time, so then you're gonna have to look and write it down, and you think, okay, I better remember that because I'm gonna have to do it again. Then you put that out of sight and go to the next problem and bring it out of memory. Don't keep bringing it out of memory, it won't stick with you. Assuming we did the assignment, that's the way you just pretty much want to do all of the assignments, okay? So anyhow, you get this. Okay, now, real quickly, it's negative b over 2a part. Okay. Now, if you do the quadratic formula with these values of a, b, and c, it's going to give you -2, -3, same as factoring. Okay. Negative b over 2a is going to give you something. Well, what's negative b over 2a? For this, b is the number in front of x, that's 5. A is the number in front of x squared, that's implicitly 1. Negative b over 2a is -5 over 2 times 1, which is -2.5. So what we're going to see next time and into next week is how this formula relates to this picture that we created without using the formula because we could factor. Okay? Factoring gives us this picture. We don't need this formula or anything, but this formula will give us everything that factoring did. Okay? Then we want to put all that together. So try to remember, review what we did here. You've written out the picture. Take a look at it every once in a while. In 5 days, we'll be back again, and then we can pick up on it. Okay? Very good. Now, the only assignment is going to be adding and subtracting rational expressions like we did for most of the class. Okay? Very good. Y'all did real well today.